Let's review row and column indexing very quickly from the earlier video. We're going to make our magic square that's 4 by 4, and I'm going to pull out the second row. B is equal to A2 comma colon. And that's going to give us row 2 all the columns, and we have that. Now, we should be familiar from linear algebra that if you have a vector, you do not need to give row and column. You can simply say, give me the first element, and that will pull out the value of 5. And you can still use the wildcard operator. So if we wanted to say B, I want row 2 colon 3, that's going to give us the second and third element, like this. And of course, if we want the last element, no matter how many rows there are, we can just say end, and it's going to pull out the 8. What some people don't know is that you can use this same single element or absolute indexing on a matrix. So if we say A1, it'll pull out 16, and since this is column major, if we say A3, it's going to count down the first column and pull out 9 for us. And what happens is that each of these columns is counted in order. So if we wanted the element 15, that would be A12. This comes very useful if we want to say, I want values, let's say 1, 3, and 12. You can make a matrix and give it as an input to the index, like this, and you'll pull out those values. Now, very often you will actually get those index values through a command like find. If we say vi, that is valid indices, that's just a variable I often like to use for this kind of operation. Valid indices, vi, is equal to find a greater than 7. And it's going to pull out those values. So now if we look at A again, and we can say A indexes vi, and we'll get all those values where A is greater than 7. So we can see how that might be useful. Let's look at B again. And we can feed it a logical index. So we could say, I want B, I want logical here, and I want the 1, a 0, because I don't want 11, I don't want 10, but I do want 8. And it's going to pull those out. Now, a very common way of getting a logical matrix like this would be to say my valid indices again are A greater than 7. And I like to put parentheses around this so it's very clear that we're doing that operation first. When we do this, we get a logical matrix, vi, and so we can say A of vi and pull out all those values again where A is greater than 7. Once you have this, you can do things like, let's say A sub vi is going to be equal to 7. So basically anywhere that the original matrix was greater than 7, we're just going to saturate it at 7. And we can see that is how that works. Thank you.